What is up, ladies and gentlemen? Welcome to day 5 of 3D printing. We've got our Ender 3 built. We have our first big calibration done. Everything's nice and tight and secured in. The first thing we're going to do next is get our file ready for our 3D printer. So if you know what a Gcode is, an STL, or a slicer, this video is probably not for you. If you have no clue what I just said, let's go through step by step and take it through it. This isn't the most exciting video, but it is necessary to make some good solid 3D prints. So, what do I have here? I've downloaded an ST file of an octopus from the interwebs, and I've uploaded it onto a slicer. Now, a slicer is going to take this STL and literally put it into slices of what the Gcode is supposed to be. So an STL is the 3D file, a 3D object. The slicer is the program, and the Gcode is the actual thing we're going to plug into our 3D printer and tell our 3D printer what to print and how to print it in temperatures and all the settings. So first thing I do is download our slicer. So let's go to the interwebs. We have Cura. Cura is a really easy slicing program. It's a big brand for Ultimaker, but it's really expensive, a 3D printer. But once you download it, you can actually upload the settings for other 3D printers. So first time you turn it on, it's going to ask about what printer you would like to add. The page is going to look very similar to this. We're going to add a non-networked printer, and then we're going to find the company that makes Ender 3s, and that is Creality. We're going to choose Ender 3, and then we're going to click Add. Now when you click Add, it'll add the Ender 3, and it'll look like this when we're done. We'll even show the little Ender 3 logo in there, or Ender logo. Looks great. So let's now add our STL file. Well, where did I get this from? I just downloaded this from the internet. There's a couple of websites out there that host STL files. Thingiverse is one of them, although they've gone under a little bit of fire recently. But this is a good STL file nonetheless. So I've downloaded it. Now let's upload it. So I'm going to go to my files, upload this octopus file, and there we go. Our octopus file is in there. We're not quite done yet though. First thing we want to do is look at our settings. So I'm going to kind of take our time going through these settings. So you have a couple of different layer heights that are going to see. So low quality prints, you can see the kind of those individual layers. That resolution is pretty low. For standard quality, it's a standard is kind of in between, and then you have like dynamic and super quality. So if you want high fine prints, some good resolution, this is what you're going to use. But the more quality, the longer the print time. So I'm going to stick with standard quality for right now. And then we're going to work our way down these settings. So we don't have to mess with quality at all. We've kind of already finished that. Actually, you know what? When you click on this, this is the thing that shows up. And I was under the custom tab automatically. Sorry, I forgot to talk about that. In any case, we have, the first thing I'm going to talk about is infill percentage. Now, by default, this is going to be somewhere in around 20%. If this piece isn't going to be under any stress, you really don't need that much infill percentage. 10 does totally fine. As far as material goes, you can see that my temperature here is a little bit different than the default. The default is 255. What I recommend is that you look on the specifications of the print you're going to use. I've got this example right here. So on the side of my roll of PLA filament, it says, recommended printing temperature, 220 degrees is kind of in the middle of what they recommend. And then bed temperature, about 50 is in the middle of what they recommend. And printing speed, 30 to 70 millimeters per second. So the recommendations are on here. However, we also have to put into account for what the ambient temperature around the environment is. If you have a nice warm temperature, you tend to not need to make your printing temperature very high. But this room is pretty cold, and I did a little bit of preliminary testing, and I found out 230 is going to be about what I need for the room I'm in, and 55 degrees. So what I found out, and this is like weeks of trial and error when I first got to 3D printing, one of two things are going to be your major issues. Either your material isn't hot enough, so you got to bump up your temperature, or your speed is too fast. Now this room is pretty cold, and so I do have a little heater that works off the side, but it is pretty chilly nonetheless. It's got a little bit of a draft in here, and so what I'm going to do then is bump up my temperature, slow down my speed, and that just helps me to assure for a more standard high quality print, and a little bit more comfortable knowing that it's most likely not going to fail. So we've got material, we have speed. The next thing we're going to look at is going to be support. For now, we're just going to say generate support everywhere overhang of 45 degrees. We're going to leave those as it is. We might unpack those later. But for adhesion type, I almost always are going to recommend for when you're getting started to do a bread. This has been the most helpful, the most successful, and honestly, I just like it the most. It wastes the least amount of material, but it also gives you the best potential of a successful print. Okay, now we're going to hit slice. We're going to be able to look at our brim, the print, how it works, where the paths are going to be. This does take a little while, so it says slicing over here, so let's move myself over to the other side. We have about halfway loaded up, and it's just literally running through, and so we click on preview. The printer, it will actually show you every level on which the printer is going to go through your code. Looks great. It'll show you where your product is or what you're trying to print. It'll show supports. It'll show infill, everything you possibly would need. And I think that's really, really helpful when you're looking at it. It's like, okay, is there going to be any problems running through this print? And I don't see anything that's necessarily of large concern. There's no overhangs, no large overhangs. Most of this is a pretty flat print, and this is honestly probably the most fun and most successful print I've ever done. So we've got it saved now. So I've got plugged in my computer. Let's go ahead and plug it and show you. We have the SD card that comes with your Ender 3, and we have the converter. We're going to go ahead and plug that into my computer. It's going to say, hey, you need to fix something. We really don't care. And then we're going to hit save to removable disk. But before we do that, I'm going to move my face again. Let's do that. Before we do that, make sure you change the name of it. It's going to be, so let's just call this, octopus. Let's call it OctSmall. And then hit save to removable drive. So it tells me that this is going to be a 5-hour print. It's going to take 20 grams, which isn't much. That spool I had earlier was 200 grams, so I could successfully print. Was it 200 grams? I thought it was more than that. This was 1 kilogram. So I could print a lot of octopi with this. Would that be in the realm of 50? Is that math right? 50 times 20? Yeah, that'd be 1,000. You could print 50 of these octopi, assuming they all, work perfectly. Okay, and there we go. We've officially got our STL file from the internet. We got Cura installed, and we got our first Gcode ready and to put it in our Ender 3. So the next video we're going to do is how to calibrate, do our final calibrations, and to get our very first print started. Guys, these videos have been fun. If this has been helpful for you, please like and subscribe. If at any point you're stuck on using your Ender 3 or some of your other printers, feel free to shoot me down in the comment section, and I'd love to help you out, or at least troubleshoot with you. Like I said, one of the two big things that I've seen is either temperature is too low or speed is too high. So bump up your temperature and lower your speed, and you tend to make a lot more successful prints. Alright guys, take care, and I'll see you in the next video.